Okay, we're starting the fifth video here. Can you do me a huge favor, Year 7? Can you make sure that you have the formulas that we saw in our last lesson written down somewhere? In your book, maybe on the sheet, maybe wherever you're doing your working. So that was C equals pi times r, and C equals 2 times pi times r. Make sure you've got them because we'll need them. Okay, off we go. 2 more examples. We're gonna be so good at pi. 2 more examples. Okay, do we have a diameter or a radius? Does it go all the way across? No, so it's a radius. I use the radius formula. Remember, twinkle, twinkle, little star, circumference equals 2 pi r. And time signs are what I left out in my rhyme, but they're actually there. Okay, so that is 2 times pi times the radius. The radius is 55. That goes into my calculator. Don't forget the ... and then my approximately equal to, and don't forget the units. Now it's a calculator problem. Alrighty, I've picked up my calculator. 2 times shift, get the pi key. 2 times pi times 55. My calculator says exactly this. I'm pressing equals. I'm going to write down exactly what my calculator says. 345.575 ... I'm not writing all the digits. 4 decimal places should be heaps. I'm only rounding to 1. Now we need to round. That's 1 decimal place. That's 2 decimal places. So after 1, I want it to be accurate to that. 7 means we go up. 345.6 centimeters. Maybe I'll make a note down here. For rounding, 0, 1, 2, 3, 4. Go down. 5, 6, 7, 8, 9. Go up. Because these are closer to the next number and these are closer to the first number. These are close to 0 and these are close to 10. All right, let's keep going. Now, is this a diameter? No, it's a radius. So twinkle, twinkle, little star, circumference equals 2 pi r. And then I know what 2 is, that's 2. I know what pi is, that's pi. And I know what r is, that's 4.2. Hey, that's a problem for my calculator. Pick up my calculator. 2 times pi times 4.2. Beep, 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 beep. Here's what it says. 26.38937. There's more digits, but that'll be enough. We're only rounding to 1 decimal place. I do my approximately equal to sign. 26 point, and I need to make sure I get it right. That's where I'm chopping it off. It's an 8, so it goes up. 26.4. Get my units from the question, and we're done. That's it. So a marker looking at this goes, do they have this line? Do they have this line? And do they have this line? And they need to all be there with all of those parts, or you're not getting the marks. It might only be worth 1 mark, but if one of those things is missing, you might not get full marks. Okay, does my answer seem correct? Well, 2 times pi is about 6, and 6 times 4 is about 24, and that's about 24. Looks good. 2 times pi is about 6. 6 times maybe sort of 50. 6 5s, 30. So maybe 300-ish. Looks about good. Somewhere between 300 and 350. All good. All right, off we go. Okay, so I've messed up the recording and I've accidentally put, I think about 20 seconds of silence at the start. So I just want to take this time to remind you that you're actually doing a really good job, Year 7. So, keep at it. You're doing really, really well. And make sure you have your formulas nearby. So I know I mentioned them on the last slide, but just mentioning them again, make sure you've got your formulas nearby. Okay, off we go. Oh no, there was even more silence. Even more silence for me to fill. Sorry about that, year 7. You might just want to fast forward a little bit. Psych, here we go. Okay, these ones are fun. These ones say exact value. Now remember, I told you can't find the exact value. You can't find it. So all you can do is describe it to somebody. So when we find the exact value, it means we don't use a calculator. Okay? Find the exact value of the circumference of each circle. And I'm going to put this here in, I'll do it in blue. You really should write this down. Exact value. It means no need for a calculator. You probably won't need one. Okay? Don't use calculator. And I'll put in brackets to find the value of pi. Because you can't. There is no exact number you can write down. So we're going to use the character pi. Okay. Mr. Johnson, you haven't highlighted the questions. I didn't know to write them down. I mean, maybe you printed out the book, in which case, you are absolutely laughing at this point. You're having a great time. First one, is it a radius or a diameter? It is a radius. Twinkle, twinkle, little star. Circumference equals 2 pi r. So far the question is the same. 2 times pi times 19. Now remember, we're not allowed to use our calculator to find the value of pi. We can't do that. Which means we do every other part of the calculation and leave this as it is. We don't replace this with 3 or 3.14 or 22 on 7 or 355 on 113. We leave it as it is. The other parts of the calculation, I've got a 2 and a 19, and they're being all multipliers. I can actually change the order of my multiplication. I can make that 2 times 19 times this number pi. We're allowed to do that. Remember, multiplication, we can switch the order. Pi times 19 is the same as 19 times pi, like 2 times 3 is the same as 3 times 2. And now 2 times 19, I know that one. That's basically 2 20s, so pretty close to 40, so 38. So it's 38 times pi. Okay. Now, could you use a calculator for 2 times 19? Absolutely, no one would know. Go for it. Pick it up, type it in, check to make sure it's 38. And now, there's one more step. If you've done algebra, then you know what this step is. And if you haven't done algebra, like my class, and I think most classes, then you're maybe a bit unsure of this step. But there's this thing called an algebraic convention that we need to know. There's a lot of these, but the one that we need to know right now is that if we have 2 times a particular number, and that number is a letter, okay? It's a letter that represents a number, maybe 5 or something, represents an unknown number, then we don't write the times sign. We say there's a symbol missing and we know it's times because we're mathematicians. Now here, we do know what pi is. We do. But it's still a letter. So we don't actually write the times sign. Remember, it's a Greek letter. We don't write the times sign. We just write 38 pi. And now I'm missing one more thing, and that's the units. Okay. Can we have a little check? Did I have a ... anywhere? No, because I didn't have a calculator printout. Did I have an approximately equal to? No, because I didn't round. That's my exact answer. All right, now, somebody looking at the page wants to give you marks. They're going to look to see, did you write down this? And did you write down that? That's what they're looking for. So if you want to have this line and then this line, that's okay. You don't need these two. If you want to write the formula, because you like writing the formula, go for it. You don't have to. These are the 2 lines they're looking for. Next one. The further you go with maths, the more times that we use the exact value because it's more precise. It's saying, I didn't use my calculator to calculate it because you might want to use more digits than I've got. You might want to take this and do something fancy with it, in which case if you've got an approximation, it could be really bad. But having the exact value could be really nice. Next question. We need to decide, is this a radius or does it go the whole way, and is it a diameter? It goes the whole way, it's a diameter. C equals pi times diameter. All right, pi times the diameter, 32. Now remember the algebraic convention? We don't write the times sign. So do I write pi 32? No. There's another algebraic convention we need to know. If we have a letter times a number, we actually switch it around. And we always put the number before the letter. The number before the letter. So y times 2 becomes 2y. Pi times 32 becomes 32 pi. Okay, that's our algebraic convention. So we have our first one here, but we don't write time signs. And we have our second one where we always put the number first, letter second. Numbers first. So the 32 before the pi. Now to finish it, make sure you have the units and we're done. Let's go check. Yep, both our lines are there, we're all good. And that's the end of that question. Okay, any calculation involving pi will lead to a decimal number that goes on forever and never repeats. If the question asks for the exact answer, leave your answer in terms of pi. In terms of pi means that there's a pi in the answer. That's what that means. Maybe I'll make that purple so it matches easier. Excellent. Okay, let's go on to the next question. Oh, this is turning into a long video, isn't it? I'll see if I can't do some of these a little bit faster. What do we need to write down? Diameter of Earth is that. We need to find circumference of the Earth to nearest kilometer. Okay, and then B, Spacelab orbits the Earth at a height above the Earth's surface. Find the distance it travels in one orbit of the Earth. Wow, that seems like a long way above the Earth, but that's actually a pretty good height. Okay. A lab orbits Earth at height of this above Earth's surface. Find distance it travels in one orbit. Okay, let's go tackle the first one. Should we draw a picture? Luckily, I've got one. Here it is, Earth. There's its diameter. There is its diameter. Okay. Find the circumference of the Earth. 1, 2, oh, blue on blue. Silly blue planet, whose idea was this? Red on blue is still pretty bad. Maybe purple on blue? No, we just can't write on it. You just can't write on the Earth, it's just too many colors. 1, 2, 7, 5, 6 kilometers. Remember, it's kilometers, not kilometers, unless you want to say kilometers, in which case say kilometers. Find the circumference of the Earth to the nearest kilometer. Circumference is pi times diameter. Pi times 1, 2, 7, 5, 6. Type that into my calculator because it doesn't ask for the exact value. 1, 2, 5, 7. Oh. 1, 2, 7, 5, 6. 1, 2, 7, 5, 6. Okay. The calculator says 40074.155 ... To the nearest kilometer. If this is kilometers, this will be the nearest whole number. So 40,074. Ones go down. I don't write 0.0, I just put my units. And we're done. 40,000 kilometers. Whoa. Have you ever been on a road trip that went for 1,000 kilometers? If you did 40 of those, you'd go around the whole Earth. Maybe next time you're in a car, if you look at the odometer, which shows how far the car has traveled, you could calculate how many trips around the Earth it could have done. If it said 80,000, it could have done 2. If it said 400,000, it could have done 10. It's a lot of trips around the Earth. All right, B. A space lab orbits the Earth at a height of 1,200 kilometers above the Earth's surface. Okay, so there's our Earth, just chilling. Here's our space lab, just chilling, just going on a nice little orbit around the Earth. And I've drawn everything sort of flattened so it's in sort of a polar orbit or something, because the third dimension doesn't really add anything to the question. Okay, so from here, I might actually use red. From here to here, it is 12756 kilometers. And maybe purple, so it fits. From here to here, it's 1200 kilometers. And the same thing over here. Just by drawing a picture, the question seems a lot easier, doesn't it? It does. So our options are to either think of this as a radius or think of this whole thing as a diameter. If you do a radius, you'll take your 1200 and you'll add it to half of this number because you just want half of it. If you want the diameter, you'll take this whole number and you'll add one lot of 1200 plus another lot of 1200. I'm going to go for that option. So my diameter is equal to 1200 plus 12756. Goodness, this number's hard to write. 12756 plus 1200. That's my distance all the way across because it's going this big circle. So I go ahead and I calculate that into my calculator. 12756, press equals, and my calculator says 15156. All right, so my circumference is pi times d, which is pi times that number. That goes into my calculator, and I write it down. 47613.97 ... I round that to the nearest whole number. I didn't show where I cut it off last time, did I? Round that to the nearest whole number, and I get 47,614, because the 9 goes up, kilometers. All right, now I'm going to do a quick check to make sure I've got that. There's another way to do this question. Yep, I've got it right. And that's good. There's another sneaky way to do this question where I can use this calculation and just add on the little bit that this extra has added. But I'm not going to do that now because that's more of a fun thing to do in like an extension question. Which is where we are now, doing some extension questions. Sorry, you might want to pause and go back to the last slide. I kind of jumped a little fast. Extension. The circumference of a circle is 102. Circumference is 102. Find radius to 2 decimal places. All right, well, this has circumference and radius, so I need a rule with circumference and radius. Twinkle, twinkle, little star, circumference equals 2 pi r. There we go. That rule has circumference and radius. What's the circumference? 102. 2 times pi times r. I don't know what r is, but I know that 102 is 2 times pi times r. I'm going to think of 2 times pi as one number. Some people use the letter tau for that. They say tau is 2 times pi, which is about sort of 6.28-ish. I'm not going to bother with that. I'm just going to think of this as one number. Now, if I have, let's pick a number that we know. If I've got, say, 36 is 9 times something I don't know, I know I could write that as a division. And if I did do that as a division, I'd say 36 divided by 9 is the number that I don't know. Can we see how we did that? Now, clearly you know this number is 4 if you're an expert at your times tables, and 36 divided by 9 is 4. So that's the plan. I've got my 36 equals 9 times something I don't know. So I'm going to write 102 divided by this. Divided by this 2 times pi is equal to r. All right, I'm going to turn that around and I'm going to write it as a fraction because we're mathematicians. You can type this into your calculator or you can type this into your calculator. I like the one with the fraction. Division signs scare me. So r is 102 over 2 times pi. That goes into my calculator. I'm going to write out what it is with a dot, 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 and then I'm going to round. Alrighty. Now your calculator is very fancy. It does some nice fraction stuff, and you can use the arrow keys to move around to make sure you're writing the right numbers in the right spots. My calculator is not that fancy, but it still works. Okay. I made my calculator say exactly that, 102 divided by 2 times pi, 102 over 2 times pi, and my calculator says 16.2338, and it keeps going. Rounding to 2 decimal places, cutting it off there, I've got 16.23, and now this is centimeters. This is also a length, so it's also centimeters. There we go. Done. Next one. This one's a lot easier. I don't even need a calculator for this one. It says circumference of a circle is 18 pi centimeters. Find its diameter. So I need a rule that links circumference and diameter. Oh. There it is. This rule has circumference and diameter in it. This one has circumference and radius. This one has circumference and diameter. Maybe this one deserves a box as well. Okay, then I just put what I know into it. The circumference is 18 pi. And if you want to write a little times, that's okay. You know it's a times there. And this is pi times d. We're going to do the same trick that we did up here. I've got some number equals some other number times something. I'm going to divide both sides by this number, and that will be what d is. So 18 pi divided by pi is d. And remember, there's little times there. If you want to have brackets, you can. So maybe I could write that as a fraction. Or maybe you know something about this. Maybe you know what pi divided by pi is. I'm going to write it as a fraction, but you don't have to do this step if you don't want to. Okay, from fractions, if I had, let's go pick some fun numbers. If I had 18 times 3 over 3, we know what that fraction, we know what fraction that is equivalent to. We know we can divide the top by 3 and divide the bottom by 3. And I'd get 18 times 1 over 1, which is 18. Now here's the thing. It didn't really matter what this number was, as long as it was the same, wasn't it? We just got 18. So given that pi is equal to pi, we divide the top and the bottom by pi, and we just get 18. They destroy themselves. Multiplying by something and then dividing by the same thing, they undo each other. So I've got 18, and my units come from the question, centimeters. Give it a tick, give it a smiley face, give yourself a high five, because nobody else can. No, I'm sure you got people to high five. Go high five literally everyone you can find inside your household. I know I'm going to. Now the next few slides are about the work that we have. I'm going to slowly go through them so that you can see the work that's there, and you could even pause it and do the work from the video. That's up to you. I'm not exactly sure what work's going to be posted. We might have found something better than what I've got here, but that's a future problem, okay? So off I go doing that. We've done all the hard work today, and it was a very long video, so the next one will be shorter. Next will be a lot shorter. Yeah, it'll be okay. So make sure you do your work. You can catch up on it for, I guess, outside of your scheduled maths lesson, or do it in the next one. There'll be some more time there. Thanks, Year 7. You've done really well today. Thanks for listening to all that. And I might put the link to Gamma Cruncher up if I remember. Okay, so as usual, we've got groups. You pick the group that works for you. Maybe you're an expert at this and you've done all this before, or maybe you've just got, yep, I can do that, and you want to start at group 3, go for it. Maybe you're like, I want lots of practice, I'm going to start at group 1, then when that gets too easy, I'm going to go to group 2, or you could stay at group 1, that's fine. Maybe you're like, oh, I'm not too sure if I'm great at this, I'm going to try group 2. Give that a go. Love group 2, fantastic group. Love group 1, fantastic groups. So here is a worksheet. I'm not sure if this is going to be set. You could always pause it, do the work from here. There's lots of questions, but they're all really, really quick. And you can see down here there's answers, so you can check. Same thing over here. This one was for group 2 and 3. The last one was for the last group. And we're going on. And then here we go. This is the last part of that worksheet. And there's the answers down there as well. So we've actually been really nice to you and put the answers. Here we go. Some challenge questions. It helps if you know a little bit of algebra for these, but you don't need to know it. Like, we were doing all that without it. So if you want to have a go at these, you can. I might give a little clue for how to do this one. Just a little way of breaking it down. That might make it easier for you. And yeah, not much to say about this one. I reckon you'll be fine. And there we go. Fantastic.